guys, I was wrong about this particular problem. I forgot I was taking a fourth root. So this guy is 2. This guy is 2. And this guy is 2. So now I think we have it correct, but it's not right on the video I just finished. So, next page. Write an equation in logarithmic form, and that's pretty easy. Log, you have the base, you have what you're taking the logarithm of, and you have the result. Well, the base is always the base. In this case, the base is 3. What the logarithm does is picks up the range, which is y, and returns it to the domain, which is m. And so that's what your answer would be log base 3 of y equals m. Now the easier is to go from from log to exponential. This is y raised to the 8 power is equal to b. That's the one we use most frequently. Evaluate the expression correct using the change of base formula. Well, if I look at log base 2 of 4, it's the log of the argument divided by the log of the base. And with my handy dandy calculator, it comes out to 2. Find x. So if I have log base 2 of 7x plus 5 equals 5, rewrite in exponential notation 2 to the 5 equals the argument. So that 7x plus 5 equals 32. 7x equals 27, so that x equals 27 divided by 7. Enter your answer as an exact value, not a decimal number. So if I have e to the 7x equals 27, I can go about this in one of two ways. I can just rewrite this as a logarithm, and this says that log base e of 27 equals 7x, which is the natural log of 27 equals 7x, or x equals the natural log of 27 over 7. Now personally, what I would have done, and it's just my training more than anything else, and the way when I've used it that way, is I would have taken the natural log of both sides because I'm using e, bring the 7x down in front, natural log of e is 1, so that 7x equals the natural log of 27, or x equals the natural log of 27 divided by 7. that's where you need, and I'm going to put a little line here, separation. That's where you need this guy, natural log of 7x plus 5 equals 5. Natural log is log base e of 7x plus 5 equals 5. Now rewrite that. 7x plus 5 equals e to the 5th, which is a rather large number. Subtract 5 from both sides. 7x equals e to the 5th subtract 5. Or x equals e to the 5th subtract 5 divided by 7. That's your exact answer. Last page. This one I had to go in and do a lot of hand correcting because of what they meant. I actually had to go in after, thank you Spencer, you took the test first, and then I saw there was a problem with this particular problem, and I went in and rephrased this as write your answers as equations, and I didn't take into account that there were more than one way to write that equation, but they had it written in a different fashion. So I thought perhaps that would have helped. It did help some, but I still had to go in and hand correct a lot of your papers. So this says find an exact solution. Well, if I know that 18x equals 19, I can rewrite this in log notation so that the log, the base is 18, it takes 19, goes back to x. That's what they were looking for. That's the answer that they were looking for. Now, on a personal level, I just don't operate on that level. What I would have done myself is I would have taken the log of both sides, or you could use natural log. Some of you did that as well. I bring the x down in front. And x is the log of 19 divided by the log of 18. Perfectly good answer. Not what they were looking for. They marked it wrong. It is written as an equation, so. But if you're going to find an approximate solution to the nearest thousandths, that's 3 places, is that you're going to have to put it into, well, either some of your calculators do this guy and some do not, but if you don't, then you have to use a change of base formula. It comes down to 1.019 using your calculator.